Hello everyone, I'm Jiaxin. I'm going to talk about the mock example paper 2, Q1D. And here's the problem. A financial analyst is interested in the percentage of revenue spent by computer software companies on search and development. A random sample of computer software companies is selected and the results are summarized in the following tables. And the problem D is construct a 99% confidence interval for the mean percentage of revenue spent by all computer software companies on search and development. State your assumptions and or approximations. First, we should find out the class marks and numbers of computers. Then it's easy to find the sum of fx, which is equal to 418.1, and to find the sum of fx squares, which equal to the 3643.99. Then it's more easy to find the division x is x square and 3643.99 minus 418.1 square over the 50 and over the 50.1, which is equal to this. Then we want to find a 99 confidence interval. So the alpha is equal to 1.99%, which is equal to 1%. And we could see our sample size is equal to 50, which is larger than 30. So from the central limit series, we should use Z to in our calculations. And from the normal tables, we could know the 1% over 2, the values. So this is the answers of mock example 2, question 1B.
Hello everyone, I am Lee Yunman Wendy and I'm in charge of the mock 3 question 4A. So the question is that a sales manager would like to compare the recent performance of two salesmen under his supervision. From the sales record, their daily sales were normally distributed with the same mean and standard deviation for 200 and 250. Amount of the sales of 10 days in the sales records will be selected randomly for salesperson. Calculates the probability that their mean daily sales will have a difference of at least 150. From the question provided, we have n equals to 10, and the first standard deviation equals to 100, and the second standard deviation equals to 250. And we have the mu1 equals to mu2. So from the information provided, the difference between mu1 and mu2 is mu1 minus mu2, and the difference between the standard deviation is that the square of standard deviation 1 over n1 plus the square of standard deviation 2 over n2. So we have the final answer that the difference between mean is 0 and the difference between standard deviation is 10,250. Because we need to find the difference of their daily sales, so we need to find out both the daily sales below 150 and more than 150. Therefore, we need to use 2 to multiply multiply the final answer. Therefore, we have 150 over the square root of 10,250. Therefore, we have sets greater than 1 from the distribution table. We have set greater than 1.48. Therefore, we need to multiply the answer by 2 and we have the final answer 0.1388.
My name is Eric. I'm doing mock examination 3, question 4B. So the question is, in evaluating the customer satisfaction level, the company would like to be 95% confident that the error in estimating the population mean does not exceed 0.05. If the population standard deviation is 0.8, what is the sample size required? The answer. So assume that the population is normal. We can get the standard deviation from the question, which is 0.8, so sigma is 0.8, and the company would like to be 95% confident. So we need to find the value of z, where the probability is 0.025. It is stated in the normal distribution table that the probability of 0.025, the value of z is 1.96. From this equation, we could see that the company does not exceed 0.05. So we substitute this equation into this, and after we solve this, we can get that n is greater or equal to 983.4, so it is 984.
Hello, I'm Jessie, and now we are talking about mock paper 3, question 4C. In a random sample of 500 theoretical employees from a large multinational company, 300 said they would like the company to adopt a flexible scheduling policy, which would permit employees to decide when and how much they would work. Construct a 90% confidence interval to estimate the population proportion of clerical employees following the flexible scheduling policy. Explain briefly how the confidence interval should be interpreted. So at first, we let the p-hat be the populations of clerical employees following the flexible scheduling policy. So from the problem, we could know that p-hat is equal to 300 over 500 and is equal to 3 over 5. So we know the interval, confidence interval is equal to the 90%. So the alpha is equal to the 1 minus 90% and is 10%. So our sample means is equal to the p-hat and which is equal to 3 over 5. And our sample deviation is equal to the x square p multiplied 1 minus p-hat p and over m and over sample size, which is equal to 0.0219. At this problem, we don't know the p, but we know the p-hat. So let p-hat estimate the p. So now we are going to calculate a 90% confidence interval. This is our formula, and our v is get from the normal table. So this is this problem's answer.
Hi everyone, I'm Marcus and I'm in charge for the mock for question 4A. In a study of turnover rate of new employee after a 1-year period, 150 new employees from various departments are selected randomly, and 29 of them are no longer employed after the 1-year period. Construct a 98% confidential interval for the turnover rate. Okay, since we need to construct a 98% confidential interval for the turnover rate, and then we just need to let happy be the population proportion of turnover rate of new employee. And then the alpha equal to 1 minus 98% equal to 0.02, and then alpha over 2 is equal to 0.01. And then the head P equal to 29 over 150, and then head Q equal to 1 minus head P, that's equal to 121 over 150. And then by the formula provided in the textbook, and then just need to sub the head P, head Q, and the Z inside, and then we can find the answer. And then from the T distribution table, we can find that the value here is equal to 2.326. Therefore, the required answer is equal to 0.1185 and then 0.2683.